Hello everyone, my name is Jorge Isaac, and in this presentation I will explain the design, simulation and implementation of the SRT and T flip-flops using VHDL in Quartus Prime Lite with the E10 Lite FPGA board. So flip-flops are basic elements in digital electronics. They are used to store information and they are a foundation for memory circuits, counters and registers. In this practice, we implemented three different flip-flops: the set reset, data, and toggle flip-flops, all synchronized with a divided 15 MHz clock signal from the FPGA. So first we created a new project in Quartus and selected the FPGA device from the E10 Lite board. Then we wrote the VHD code that describes the behavior of the three flip-flops. Inside the code, we include a clock divider to slow down an internal 15 MHz clock, and this was done with a 26-bit counter, and I use bit 20 to produce a lower frequency clock signal called clock out. This lower signal help us to visualize the flip-flop operation with the board slits. Each flip-flop was implemented as a separate process. The SR flip-flop follows the standard logic. It sets, reset, or holds the output depending on set and reset. The T flip-flop simply transfers the value of input T to the output Q at each clock rising edge. The T flip-flop toggles its output on every clock pulse when the input T is active. The outputs of each flip-flop are duplicated Q and its inverse Q and to observe both the true and complement states on the LEDs. So we go to the VHD, which is the code for the test bench to simulate the circuit. So in this file we generated a clock that switches every 10 nanoseconds, and I apply different input combinations of S, R, and T to test all possible cases. We use LTA viewer to run the simulation and check the waveforms. The results showed that all flip-flops behave correctly. The SR flip-flop reacted to set and reset inputs. The D flip-flop followed the D input, and the D flip-flop alternated its state with each clock pulse. So let's go to the assignment editor or pin planner. So here we have the assignments from each variable. For clock 15 MHz, we have the pin P11, that is the internal clock of the FPGA. The LED clock out, which is the slower clock that we are going to use and to show in the LED. Reset clock to stop the clock with the switch 812. The input S, the set, that is in C12, reset D12, D in C11, and toggle in C10. And all of these are the outputs of our FPGA. So we have to the LED 5 to LED 0, and we with each pins correctly. So let's program the FPGA. You click on here on programmer, and you click then and start. And you wait until the progress is 100% and it's uploaded. So let's go to the FPGA board. So here we are on the FPGA, and this LED is the clock. LED 5 and LED 4 is are the outputs of the SR flip-flop. So we have set and reset. I think it's this. Yes, this is set and reset. Sorry, this is for stop the clock. So this is set and reset. We have the next one is the flip-flop D. So when it's on, it shows 1, 0, 1, 0, and 1. So this switch is for the flip-flop toggle. So when it turns on, it toggles the output, so it's switching every time the clock is changing. So when you stop it, when you turn off the switch, it turns off the switching LEDs. So that's it, and see you in the next video.